Alrighty, this is my video number 6. I'm going to talk about digital signatures and digital certificates. I'm going to also talk about security tokens, digital certificates, and digital and XML certificates. So, we have entered a time when conveniences of widespread connectivity, including the cloud, have put us at a risk than ever getting hacked. So when the data falls into wrong hands, the consequences can be devastating. So there is a time-tested science that is increasingly becoming a crucial link in the security chain, which is chain encryption. Encrypted data cannot be read without passwords or security key, which then enables to decrypt it. It has become much more of must-have options than add options to slow down and even deter hackers from stealing sensitive information. So while IT security seeks to protect our physical assets like computer, database, server encryption protects the data that lives on and between those assets. So how does that work? So this is, as you can see, there is just a protect your data with encryption. This is a very simple sentence, and when you convert that into 39-bit encryption key, this is how it's going to look, which is very hard to read and remember. Yeah. So if you encrypt data before syncing it with cloud, the cloud or any other who is breaking it cannot read that data. Even iPhones are encrypted to protect that data in case if we lose them. So on a severe note, encryption can be bad too. Ransomware attacks are becoming more prevalent, also called denial of services attack, that use encryption software to lock users out of their computers until they pay fee. So there are two types of encryptions, at rest and at transit. If a computer hardware or database is hacked, encryption makes the data unreadable. If the data that is in transit, like a between browser, email, or anything, encryption keeps it safe. So this is the data at risk, which is kind of a plain text that is encrypted into jumbled, unreadable ciphertext by an algorithm. Second is ciphertext that is decrypted back into plain text with the SSH or encryption key, a long string of numbers, the algorithm which I just showed you in the previous slide. So what are the algorithm types? I'm not going to read each and everything, because if I try to do, I won't be able to finish video in given time. So I'm just trying to review the important key points again. So what are the algorithm types? There are AES, Advanced Encryption Standard, that is pretty much the global standard per US, which offers 128, 192, and 256-bit encryption. RSA, there is IDEA, there is a single protocol that is open source encryption protocol used for asynchronous messaging like email. There is Blowfish and Twofish. Both of these block ciphers are free to use and popular among e-commerce platforms. Ring learning with errors and Ring LWE. What are the encryption types? Secret key algorithms, public key algorithms, block cipher. This is triple DES, uses 3 keys and pretty great encryption option for financial institution that needs more protection. There is a stream cipher encryption, elliptical curve cryptography. There is a blockchain cryptography, that is a type of distributed database best known as a Bitcoin, basis for Bitcoin, that uses cryptography to safely store that data about financial transaction. Let's move next. Key management and its importance. So how to handle them? Why do we need to handle this key? Because this is, again, it's very important to handle them in case if that comes into wrong hand or something, your data can be read by anyone. So if you lose your encryption key, you might also lose your data. So this is where we need to maintain that key. So how do we maintain that? So there is a Diffie-Hellman key exchange. This is a secure way for people to create a key that allows to share secure information. This method is also touted as perfect forward secrecy, which means that in future, at no point in future can message encrypted with this key can be decrypted. There is also double rashid algorithm, which is used in end-to-end encryption of instant messaging like Signal messaging app. So now let's move to security tokens now. First line is hard to read. Authentication token is a small hardware device that owner carries to authorize access to a network services, which may be in form of smart card or soft card or hard card. I mean, yeah, soft token or hard token. So soft token is a software-based security token that generates single-use login PIN. Why digital signature is required? Certificates serve as a proof of identity for any organization for certain purpose online or computer. So these signatures can be represented electronic to prove your identity, to access information or services on the internet, or to sign certain documents digitally. At the end of the video, I'm just going to show you Paripeti, how to generate SSH or any kind of the key that you need using Parigen. So that's digital certificates. They are used to verify that a user sending a message is the one who claims to be and provide the receiver with the means to encode a reply. What are the different type of digital certificates? There are certificate authority certificates, and there is a server or client certificates. Again, I'm not going to talk about all this in detail just because time constraint. There is also object signing certificates, there is signature verification certificate, user certificate that validates the identity of the client and user that owns it. So digital and XML signature, type of electronic signature that encrypts document with digital codes that are particularly difficult to duplicate. So the purpose of this is that it guarantees that a person sending the message really is he or she that claims to be. They are important for electronic commerce and are the key component of most authentication schemes. So for example, in this picture, Amy, she's trying to have that letter which has message digest by using mathematical function. She has her private key and then she's sending over to the internet. Ben, who is then upon receiving this email, he's just going to verify Amy's digital signature using her private key, and then she's just going to compare the other one and then verify if that is the same mathematical function that he needs to go ahead. So what are the type of digital signature? There are class 2 and class 3, and how do we get that? Reputable certificate authoritative such as Comodo, or we can create it on our own. So we can create on our own. So this make more sense in business scenario as it assures a recipient that it was genuinely seen by you, not by some impersonator. So what is the use of this? So because computer tenaciously pairs a digital signature to one saved version of the document, it is nearly impossible to replicate a digitally signed document. So if you're a developer selling distributing software online, you may need to reassure your customer that you are executable really from you. Okay. And there is also XML signature is an XML representation of a digital signature applied to over arbitrary documents. XML signatures are more flexible than other form of digital signature because it does not operate on binary data but on the XML info set, which is most secure thing. What are their type? They are enveloped and enveloping. So if it contains enveloping, it contains the signed data within itself, and envelope has signed some part of its containing doc. So I'm just going to show you how to generate SSH or any kind of the key that you want, and you just need to generate, and then it's going to generate a key for you, and then you can use whenever you want, and then for your safety purposes. And that's all for video number 6. If I'm missing anything or any relevant topic, please do let me know so I can add that into my video. And that's all for video number 6. And this is how it has generated this is RSA key, so I can also generate SSH key and then generate and then click, and that's all for this video. Thank you for watching.